Textbook 2.4 Question 9.
Okay, now have a look at this question. Okay. So what's happened is, on voltage and current graph. Okay, this is a VI graph. Okay, so yeah, normally it looks like that. Okay, on a VI graph, and we know V equals to IR. Okay, so the gradient of the graph, there's a little bit of math. Remember in your method we learned that the gradient, okay, um, well, let's just say this, okay, the gradient of the graph, gradient, okay, is R. Okay, means the gradient is the resistance. Okay, so the steeper the gradient is, the higher the resistance. Okay, however, in this case, okay, I have a current and voltage graph. Okay, current and voltage graph. Okay, IV graph. So if I manipulate this formula, okay, I equals to V on R. Okay, what we can say is, okay, now let's rewrite it. Okay, I equals to 1 on R times V. Okay, the gradient of this graph, the gradient of IV graph, okay, is going to be, in this case, the gradient is going to be 1 on R. Okay, so the idea is, okay, now it's 1 on R, so it's inversely proportional. So if the gradient is higher, means the resistance is lower. Okay, it's completely reverse to the situation above. Okay, so on above situation, what's happening is the gradient increases, so the resistance increases. Okay, underneath, what's happening is the gradient increases, okay, and the resistance decreases. Okay, so as a result, okay, on a current voltage graph, okay, the less the slope, the less the gradient it has, then the greater the resistance. So Catherine is right. Okay. The lower the slope, it has the higher resistance. Okay. So in the exam, if you need to do that, the best way, if you need to explain this, the best way would be just using math. Okay. Just write down the equation, write down this. Okay. The gradient is 1 on R, means the gradient increases, the resistance decreases. So, okay. So Catherine is right. Okay. And that's done.